principle of reversibility. Okay, what does it mean? The principle of reversibility means that the light will, the path of the light is reversible. Okay, the path of light is reversible. This is a very important principle. What does it mean? It means we have a surface, it's just prime. This is the normal, and this is the incident ray, and this is the reflected ray. So incident ray after striking the surface gets reflected like this. And the principle of reversibility says that if the incident ray is along this direction, then it will follow the same path. The reflected ray will be the previous incident ray. That's what it means. That means this incident ray, the original direction of incident ray is towards this, no? This is the incident ray, and it gets reflected like this. And the principle of reversibility says that if I consider this as the incident ray, then OA will be the refracted ray. Okay, it cannot be any other ray. The OA has to be the refracted ray. From there it is said that the path of the light is reversible. Okay, so that's the principle of reversibility, and we use this principle to find one important relation. So OA is the incident ray and OB is the refracted ray. I is the angle of incidence, R is the angle of refraction. This is medium 1, this is medium 2. So refractive index of medium 2 with respect to medium 1 is sin I by sin R. Let's call it equation 1. Okay. Now the principle of reversibility says that if I consider this as BO is the incident ray, then OA has to be the refracted ray. It cannot be any other ray. It cannot be any other ray. It will follow the same path. It will retrace its path. So, okay, if you consider OB is the BO is the incident ray and OA is the reflected ray, then the refractive index of this medium 1 with respect to medium 2 would be given by this sin R by sin I. No, in this case, we have to consider this as the incident ray. This is the refracted angle. This we have to consider incident angle. This we have to consider the refracted angle. Therefore, we have to use sin R by sin R. So refractive index of medium 1 with respect to medium 2 is then sin R by sin I. Refractive index of medium 1 with respect to medium 2 is sin R by sin I. Simple, which is equation 2. Now what do you do? We multiply equation 1 and equation 2. So equation 1, refractive index of second medium with respect to the first medium, refractive index of the first medium with respect to the second medium equals to, just multiply it, we get 1. So from there we got very important relation. So mu2 1 equals to 1 mu1 2. Okay, that means refractive index of the second medium with respect to the first medium is inverse of the refractive index of this first medium with the second medium. Okay, for example, if the refractive index of glass with respect to air is 3 by 2, then the refractive index of air with respect to glass will be 2 by 3, just the inverse. So if you choose the air is the first medium and glass is the second medium, okay, if you choose the air is the first medium and the glass is the second medium, and the light is traveling like this, then the refractive index will be 3 by 2. But if you choose glass is the first medium and air is the second medium, and the light is traveling like this, then the refractive index will be just the inverse of that. If it is 3 by 2, it will be just 2 by 3. So this is very important relation which comes from the principle of reversibility.